Do you know offshore platforms are one of the biggest structures that we can build with our current technology? Each offshore platform carries all the equipment needed for operations such as extraction and storage of oil and gas from the field. These offshore platforms, however, are built to withstand the harsh conditions that most man-made structures fail to withstand. The reliability of these platforms are being put to the test during the operation of extracting oil and gas from the reservoir. Although these platforms are being designed to have a lifespan that covers the entire estimated time required to extract all oil and gas from the reservoir, the platforms may need to extend their lifetime when there is still oil and gas remaining to be extracted. Before this can be done, the reliability of the structure needs to be assessed. There are various methods being used by structural engineers in analyzing the reliability of the structure. Reliability can be understood as the chances for something not to fail. So, to find the reliability of the structure, they find its complement, the probability of failure. Most structural engineers simulate various loads acting on a structure and use the data acquired from the simulation to calculate the probability of failure of the structure. Simulation-based and statistical software are being used for this purpose. In the fourth industrial revolution, the application of data science has become a trend that all industries tend to follow. Data science is a field in which a phenomenon can be described with data that has a specific pattern. The analysis can be done by artificial intelligence, or AI for short, which is another feature that most industries are aiming for. So, the question of the day: is there any way we can apply data science in the structural reliability assessment? Here, I have an idea on how to do it. We can develop an algorithm for the AI to do the calculation. You might wonder, what is an algorithm? Let me give you an example. Imagine you have a book recording your pocket money for the whole day. Now, let's give it two things to be recorded. One is the reward for helping someone, another one is the money spent for buying a drink. Normally, we will add the amount we receive and minus the amount we spend. So, this is the rule we apply. Now, don't be surprised if I tell you this is an algorithm that we will write for the computer to follow when the computer does the recording for us. So, for the structural reliability analysis, the algorithm works like this. First, the algorithm will try to fit the data given with a pattern that best describes the data. These patterns, known as distributions in statistics, are described in the form of equations. The algorithm will then perform statistical analysis to find the probability of failure, which most of the process is just basic mathematical operations, since integration can be understood as the sum of data that is obtained from an equation describing it within a range. This algorithm actually automates the whole process that is done manually by structural engineers. Now, to develop the algorithm, I will use Python. Python is a programming language that is well known and most used in scientific computing. The reason I choose Python over other programming languages such as Java and C++ is because 1. Python is easy to learn, even for those who do not have any basic programming knowledge. 2. Python has the simplest syntax, or format to write a command for the computer to run. Here's an example between Java, C++, and Python that will give hello world as output of the program. The first line for each one is the command, which will be ignored by the computer. Pretty easy, right? 3. Python is supported with many libraries, or collections of functions developed by other developers. What kind of functions, you may ask? So, the example of functions includes the function to plot a chart, to perform conversions of units, and to perform complex mathematical calculations. These functions consist of lines of code that make them work as intended, or in simple English, simple things make a complex thing work. 4. Python is most used by data science community, so there's a lot of information to refer for when certain errors have popped up during the development process. And lastly, Python is free for everyone. The application of data science in engineering analysis has a huge potential in the future, in which predictive analysis can be developed in addition to the AI that can handle real-time analysis with massive amount of data.